Hello everyone, welcome to Sai Niketan online classes. So in this class we will start with the new topic, that is applications of integrals, right? So from this topic you have totally 8 mark for your annual examination. There is a 3 mark one question and there is a 5 mark one question, right? So totally in this topic you have 8 mark. Out of 8 you have the 2 questions, one is 3 mark question and another one is a 5 mark question. And in this topic you have 2 exercise, they are 8.1 and 8.2. 8.1 is related to area under the simple curves, how to find area under the simple curves, and 8.2 is related to area between the two curves. Okay, now we will start with the topic application of integrals. To study the applications of integrals, first you should know what is mean by indefinite integrals and definite integrals. So I think already you have completed the integrals topic. So in that, so first one is indefinite integrals, right? Indefinite integrals. So the integral of the type integration of f of x into dx is equal to f of x plus c. So these are called indefinite integrals, right? So and already you have studied about this and you have studied some of the various forms of the integrals, how to solve the integrals by using the method of substitution, by using by the method of partial fraction, and you have studied the solving the integrals by integral by parts, right? So those are the some methods to solve the integrals. Next, the second type of the integral is, so that is definite integrals, right? So this is a very important to study the applications of definite integrals. The definite integral, they are in the form of integration of a to b f of x into dx. So this is equal to f of b minus of f of a. So such type of the integrals are said to be definite integrals, right? So here a is called a lower limit and b is called a upper limit. The integral of this function we will write f of b minus of f of a, the functional value at upper limit minus the functional value at lower limit, right? So you have studied in the topic integrals, right? So here a is a lower limit and b is a upper limit. So in this topic, what are the main applications of the integrals? The applications of integrals is always to find the area under the curve. But you already know that how to find the some of the areas, some of the standard areas of the geometrical shape. For example, you know that how to find the area of a square, and you also know that how to find the area of the rectangle, and you know that the area of the circle, right? So instead of these standard results, standard geometrical shape, suppose if you want to find the area under the curve, suppose if it is x-axis and here it is a y-axis and here it is a origin. Suppose if the curve is like this, suppose if you want to find the area of this region, right? To find the area under this curve, instead of some standard geometrical shape, if they have given the if they have given the curve like this, then how we have to find the area under this curve? So to find the area of this curve, we are using the definite integral. And also if you want to find the area between the circle, if you want to find the area between the circle and a straight line, suppose if you want to know what is the area of this region, this region is includes the circle and a straight line. In that case also we are using the definite integral. Suppose if you want to find the area of such curve like this, suppose if you want to find area of such region, then also we are using the definite integral. And also if you want to find the area between the two parabolas, suppose if it is a parabola like this and if it is a parabola like this, suppose if you want to find this area, right? To find this area is bounded by the two parabolas, that is y square is equal to 4ax and x square equal to 4ay. So in such case also we are using to find the area of such region, we are using the definite integrals, right? Okay, now we will study all these one by one. Okay. So here the first one is the area between the simple curve, right? So the first application or the first in this topic we will study area under the simple curves, area under the simple curves, right? After that, after completion of this, we will study the area between the two curves, right? So here area under the simple curve, so in this I will take the first one, right? The first one is area bounded, area of the region, area of the region, right, bounded by the curve, y is equal to f of x with the x axis with the line x equal to a and x equal to b. Then how we have to find area of such curve? So for this, here I will take, so this is a x axis and here it is a y axis and here it is a origin. Suppose if you want to find the area of this curve bounded by this curve, that is y is equal to f of x, so this is a given curve. Suppose if you want to find area of this area of the region bounded by this curve with the line x equal to a and with the line x equal to b. Suppose if you want to find this area, right, to find this area, okay. So in this case, how we should use or how we have to find this area? By using the definite integrals, right? So here I will call this as a. Here you should observe this is the curve y is equal to f of x and this area is lies on x axis with the line x equal to a and x equal to b. It means that you have to find the area from a to b and this area is lies on x axis. So in this case we will use the formula area is equal to integration of a to b f of x into dx. So this is the formula to find area of the region bounded by the curve y is equal to f of x with the line x equal to a and x equal to b. So that is given by the formula a is equal to integration of a to b f of x into dx. So but f of x, what is the value of f of x? That is y. So we will write like this: a is equal to integration of a to b f of x. F of x is nothing but y into dx. So we will use this formula to find the area, okay. And also this area is lies above the x axis. So this area is lies above the x axis means so clearly this area is lies in the first quadrant. In this case we are using this formula. Sometimes the same, suppose the area is lies on the same x axis. So here it is x axis, here I will take origin and here it is a y dash and here it is a y. The same curve, that is like this. So this curve is y is equal to f of x, right, with the lines x equal to a and with the line x equal to b, right. So if you want to find this area, right, so here also you should observe this area, right. So again this area is lies on x axis only, right, on x axis only from the line x equal to a to x equal to b. So here if you want to find this area, again to find this area, again we are using the same formula. A is equal to integration of a to b, and here it is f of x into dx, right? So, but to find area, this area is lies in a fourth quadrant. So we already know that area is always positive. The area is not a negative. So if you find area of this region, suppose if you are getting a negative, then you have to take the positive of the area, or here you should take the mod of integration of a to b f of x into dx, because here I have taken mod because area is always a positive, hence I have taken the negative. So clearly this area, this is lies above the x-axis, above the x-axis. So this is the first case, right? And this is the below the x-axis, below the x-axis. If it is below the x-axis, then you have to take the mod of integration of a to b f of x into dx. So if it is lies in or if it is lies in above x-axis, then you have to take integration of a to b f of x into dx. But what is the value of f of x? That is y into dx. So here also we will write like this, integration of a to b. What is the value of f of x? That is y into dx. Take the mod. Okay. So this is about area of the region bounded by the curve y is equal to f of x with x-axis, with the line x equal to a and x equal to b. So in this case we are using this formula. Okay. So again, if we want to find area of the region bounded by the curve, suppose the curve is in terms of x, so that is x is equal to f of y, x equal to f of y with y-axis, with the line y equal to c. Here I will take y equal to c, and here I will take y is equal to d. In this case, how we have to find the area? So for this I will write the function, I will write the curve. That curve is lies on y-axis, right? Okay. So again, the area of the region bounded by the curve x equal to f of y-axis with the line y equal to c and y is equal to d. So that is like this. So here it is a x-axis, here it is a y-axis, and here it is a origin. Suppose this is the curve. That curve is x equal to f of y, and with the line y equal to c, and here it is y is equal to d. The line y equal to c means it is a line parallel to x-axis. Y is equal to d means again it is a line parallel to y-axis. Suppose if you want to find this area, so here you should observe, this area is lies on what? So this area is lies on y-axis. So in this case we are using the formula integration of area is equal to integration of c to d. So here it is f of y into dy. So here we are using this formula to find the area of the region bounded by the curve x equal to f of y, and this area is lies on y-axis. So again here we will write like this, integration of c to d. What is the value of f of y? F of y is nothing but x, so x into dy, right? So here we should find the value of x. The value of x that gives the in terms of y. So in that case we are using integration of c to d, x into dy. And again here you should observe this area lies right side of the y-axis. Similarly, if it is like this, so here it is x dash, and here it is a y dash, and here it is a origin. Suppose if you want to find, here I will write. So if it is like this, so here it is x dash, here it is y, o, y dash, right? Instead of lying the area right side of the y axis, sometimes it may lies here, right? So here it is y equal to c and here it is y is equal to d if you want to find this one, right? So in this case we are using the same formula, integration of c to d, that is f of y into dy. So for this here we will take the mod, because after solving this, if you are getting the negative, we know that area is not a negative quantity, so hence we have to take the mod, right? So this is about formula to find the area of the region bounded by the curve y is equal to f of x on x axis and x equal to f of y on y axis. We are using this formula, right? So again we will study, suppose the area is bounded by the curve y is equal to f of x. So here I will remove this one. Suppose if you want to find area of the region bounded by the curve y is equal to f of x, it is like this, y is equal to f of x, right? And intersect x axis at point c, with the line x equal to a and x equal to b with the x axis. Then how we have to find the area of the region bounded by the curve y equal to f of x, intersect at x axis at point c with the line x equal to a and x equal to b. So for this I will draw the curve. That curve may be like this. So here the curve is here x axis origin, here it is a y axis. Suppose the curve is like this. Suppose if you want to find the area of the curve, this curve is y is equal to f of x with the lines. So here the line is x equal to a and here the line, this line is x equal to b and it is intersected the x axis at a point x equal to c, right? Suppose if you want to find areas like this, if you want to find the areas like this, right? If you want to find this area and also if you want to find this area, right? So here you should observe the required area, that is a1, I will call a1 and a2, right? So clearly this area is lies on above the x axis and this area is lies below the x axis, and this curve intersect the x axis at point c from the line x equal to a to x equal to b. Suppose if you want to find the required area, that is equal to what? a1 plus of a2. If you want to find this one, because the total area, that is this is a a1 and this is a a2, if you want to find this area also and this area also, I will write like this: required area is equal to a is equal to a1 plus a2. Then what about a1? So therefore a1 is equal to a to c. Here you have to take a to c. So here it is a to c, here it is f of x into dx, right? And here it is a2. a2 is what? That is you have to take from c to b. So here it is c to b, again here it is f of x into dx. Is it right? And this area is clearly lies below the x axis. So in this case you have to take the mod. Therefore the required area will write like this: therefore integration of a to b f of x into dx plus integration of c to, so here it is integration of a to c and here it is c to d f of x into dx, but for this you have to take the mod. So this gives the area of the region bounded by the curve y is equal to f of x. This curve intersect the x axis at point c from the line x equal to a to x equal to b. So in this case we are using the required area, that is a is equal to a1 plus a2. a1 is given by integration of a to c f of x into dx, and a2 that is given by integration of mod of integration of c to b, here it is c to b f of x into dx. Okay, where you should remember this one also. Okay, next we'll go for the next type of the curve, area between the two curves, area bounded by the two curves, area of the region bounded by the curve y equal to f of x and y is equal to g of x. So here I will take y is equal to g of x. Area is lies on x axis with the line x equal to a to x equal to b. The similar concept we have to apply for y axis also. Just have to interchange the function. So here if it is like this, right? So here it is x axis, here it is y axis, and here it is a origin. So this is the curve y is equal to f of x, right? And I will take one more curve, that is y is equal to g of x. So in this case we will take like this, f of x should be greater than or equal to g of x, right? So this curve is more than this curve. So here if you want to find the area between the curve y equal to f of x and y equal to g of x from the line x equal to a to x equal to b, right? So if you want to find this area, right, this is the required area, right? So in this case how we have to find this, I will call E, right? So clearly to get the required area we will take a1 minus of a2. So in the previously we have taken this as a1 plus a2, but here I have taken required area equal to a1 minus a2, because if you want to find this area only, first you should find area from this point to x axis. After that just you have to subtract the area from the second curve to this one, right? So from total this area you have to subtract this area, you are getting this area, hence the required area will write a1 minus of a2. Is it right? a1 minus of a2. So therefore here what is the value of a1? a1 here I will find a1 is equal to integration of a to b. So here it is f of x into dx, because the curve y is equal to f of x is there. So therefore from a to b we have to take the first curve. So therefore a to b f of x into dx. Similarly if you want to find a2 means the same line, they are from a to b only, the limits are same but the curve will change. What is the curve? This curve is y is equal to g of x. So therefore clearly g of x into dx. So substitute these in this equation, that gives a1 minus of a2. What is the value of a1? So integration of a to b f of x into dx minus a to b g of x into dx. So this gives the formula to find the area of the region bounded by the curve y equal to f of x, y equal to g of x. This area clearly lies on x axis with the line x equal to a and x equal to b, and here it is f of x is more than or equal to g of x. So in this case we will take the area that is equal to a equal to a1 minus of a2, right? So these are the some formulas or some area of the region bounded by the simple curve. So if they are the simple curve, they are given only one curve. For example, they will give you to find the area of the parabola and a straight line. In this case we are using these formulas. And if they want to ask you to find the area between the circle and straight line, in that case also we are using such type of the problem, right? So here whatever I have discussed, just you have to take the screenshot and you have to write in your notes, then it is very easy, then that will help you to solve the exercise problem. Okay, now I will start with the exercise. So before starting the exercise, first you should know some of the symmetric properties. Before solving the exercise, first you should know some of the symmetric properties of the curve, right? So here I will write some important notes. Note that is a symmetric properties of curves, right? So these are the symmetric properties of the curve, right? So in that first one, here I will write, if all the powers of x are even in the given equation of a curve, then the curve is symmetric about x-axis, right? So for example, if you want to find the curve is like this, that is x square is equal to 4ay. So here the equation of the curve is like this, x square is equal to 4ay, right? Suppose this is the curve x square equal to 4ay. So here you should observe, here it is the even power of x is there. So what is the power of x? 2 is a even. So in this case the curve is like this. The curve is, so here it is x-axis, here it is a y-axis, and here it is a origin. So in this case it is like this. So this what it represents, it is x square equal to 4ay. Because x square equal to 4ay means, so clearly it represents equation of a parabola, and this equation of a parabola which is passing through origin, and it is symmetric about y-axis. So if you fold this curve along the y-axis, so then you are getting this curve is symmetric about y-axis only. So therefore, to remember this one, so to remember this equation, just you have to observe the power of x. If all the powers of x are even in the given equation of a curve, then the curve is symmetric about curve is symmetric about y-axis. Okay, so this curve is symmetric about positive y-axis. So similarly, if you take like this, so that is x square equal to minus 4ay, right? If you take x square equal to minus 4ay, again it is a curve symmetric about y-axis only. Here y, here it is origin. So in this case, this is y dash. So what it represents? This represents equation of a parabola, and this curve is symmetric about negative y-axis. So it is negative y-axis because it x square equal to minus 4ay. If it is x square equal to 4ay, then the curve is symmetric about positive y-axis. So just you should remember this point. So in a given equation of curve, if all the powers of x are even in the given equation of a curve, then the curve is symmetric about y-axis. Okay, similarly I will change this one. If it is like this, if all the powers of y are even in the given equation of a curve, then the curve is symmetric about x-axis. So this is the second case. So here I will take this as a second. So that is, if all the powers of y are even in the given equation of a curve, then the curve is symmetric about x-axis. So for example, if it is like this, so here it is x, and here it is a y, here it is a origin. So the curve is like this, y square is equal to 4ax, right? So in this case again what it represents, so it represents equation of a parabola, that is y square equal to 4ax, y square equal to 4ax. So in this case the power of y is even, therefore it is symmetric about positive x-axis. So just you have to observe the power of y. If the power of y is even, then the curve is symmetric about x-axis. So if it is like this, y square equal to minus 4ax, right? So in this case like this, so here it is x, here it is x dash, and here it is a y, y dash. So if it is like this, so what it represents? It represents equation of the curve, that is y square equal to minus of 4ax, right? So if it is minus is there, then it is symmetric about negative x-axis, and also in both the equation the power of y is even. Therefore you should remember, in a given equation of a curve, the curve is having even power of x, then that is symmetric about positive x-axis and negative y-axis depending on the curve. If the given equation of a curve having even power of y, then it is symmetric about x-axis and symmetric about the positive x-axis and symmetric about negative x-axis. Okay, next I will go for the third one. Just have to take the screenshot of all these. Okay, if all the powers of, here I will take x and y, all the powers of x and y are even in the given equation of a curve, then the curve is symmetric about both the axes, about both x-axis and y-axis, right? So here the given equation of a curve, they are like this, x square plus y square is equal to a square, right? So in this equation of a curve, here both the power of x and y are even. Here the power of x is 2, the power of y is also 2. In such case the curve is symmetric about both x-axis also y-axis, or what it represents, so it represents equation of a circle. So clearly this circle is symmetric about x-axis also, y-axis also. So here if you fold like this, then it is symmetric about y-axis. If you fold like this, then it is symmetric about x-axis. So because just you should remember the power of x and y are even, then it is symmetric about both x-axis and y-axis. And I have one more example, x square by a square plus y square by b square is equal to what? So what it represents? So it represents equation of a parabola with a is more than b. Here you should observe the equation, here in this equation of a curve, both the power of x is also even, y is also even. So in this case again it is symmetric about both x-axis and y-axis. So here it is like this, right? So here it is a major axis and b is a minor axis, length of the major axis and length of the minor axis. So just you should remember these points. So these points are helps to you to solve the exercise problems. So that is the third one is, so that is if all the powers of x and y are even, then the equation of a curve is symmetric about both x-axis and y-axis. And also if in a given equation of a curve, if the power of x is odd, the power of x is odd, in this case the curve they are symmetric about opposite quadrant. Here origin x o x dash, here it is y o y dash. So here y equal to x, here you should observe it is a odd power of x, hence in this case this is the curve or it is a straight line that is symmetric about opposite quadrant. Okay, so here y equal to x means a line passing through origin, and if you fold like this, then it is a symmetric about opposite quadrant. If you take y equal to x cube, so again the curve is symmetric about the opposite quadrant. So therefore you should remember this point also. And here you should remember one more point, that is fifth point. If the equation is like this, x equal to a and another one is y equal to b, right? So what it represents, if x equal to a is there, so clearly it is a line, parallel to x axis, parallel to y axis. So here it is parallel to y axis. Okay, next, if the equation is like this, y is equal to b, so in this case the line is parallel to what? So x axis. So just you should remember these 2 points. If the equation is like this, x equal to a, then this is the line parallel to y axis. If y is equal to b is there, then the line is parallel to x axis. So for example, if they have given like this, x equal to 2 they have given, then how we have to take? Now it is in the form of x equal to a. If x equal to a, the line is parallel to y axis. So here you should take here origin x. The value of x is here. Just you have to take the line like this. So this is the x equal to 2, and this x equal to 2 is parallel to y axis. So similarly they given like this. So if they given y is equal to 3, then how we have to draw y equal to 3? So again here it is like this, x axis, y axis, origin. Here the value of y is, here it is 1, it is 2, and here it is 3. So this is y equal to 3. So y equal to 3 means it is a line parallel to x axis. If x equal to 3, then it is a line parallel to y axis. So therefore you should remember these points. If you remember all these points, then we will solve the exercise problems very easily. So these are like key points. Okay, now I will solve one simple problem in this class. Next class we'll start with the exercise problems. So okay, here the area of the region bounded by the curve y is equal to, or y square is equal to 4x, y axis, y square is equal to 4x, y axis, and the line that is y is equal to 3. Okay, here we should define this one. Okay, here we should find the area of the region bounded by the curve y square equal to 4x with y axis and the line y equal to 3. Okay, here first you should see, here y square equal to 4x is there, y square is equal to 4x is there. So clearly it is a even power of what? Even power of y. If it is a even power of y, then the curve is symmetric about what? Metric about x axis. Is it right? If it is even power of x is there, then it is symmetric about y axis. If it is a even power of y is there, then it is a symmetric about x axis. So here we should take the rough sketch of this one. So here it is x axis and here it is a y axis. So here it is like this. So what it represents? So this represents y square equal to 4x. So clearly it represents equation of a parabola which is passing through the origin. Okay, next. Now what they have given? We have to observe. Then with the y axis they have given and the line y equal to 3. What is the meaning of y equal to 3? Just we have discussed, y equal to 3 means it is a line parallel to what? that is x-axis, parallel to x-axis. Now here it is 1, here it is 2, here I will take 3, right? So y equal to 3 means we have to take the line, that line is parallel to x-axis. So here it is like this. Okay, now here you should observe what is the required area. The required area is this one. The required area is this one. Okay, we should find this region, right? So here clearly this area is lies on y-axis. So you already know that the formula, the area of the region, area of the region bounded by the curve, that is x equal to f of y, with y-axis, with the line y equal to c and y is equal to d. What is the formula? That is a is equal to c to d, that is x into dy. You know this formula, right? Now, so for this question, what is the value of c? So here we have to find the area from 0 to 3. So therefore clearly we will write like this. So that is 0 to 3 and x into what? dy. Okay, now we should find the value of x. So here what they have given? They have given y square equal to 4x they have given. Now we should find the value of x. So therefore y square divided by 4 is equal to what? X. So this gives the value of x. Now I will substitute the value of x in this equation. So what you are getting? That is 0 to 3. What is the value of x? So that is y square divided by 4 into dy. Okay, now simplify this one. So therefore remaining thing I will write here, right? Will write here. Okay, next. So here a is equal to, I will take 4 outside, so 0 to 3, and here you are getting y square into dy, right? What is the integration of x square with respect to x? That is x cube divided by 3. If it is y square with respect to dy means what is the formula? Therefore 1 by 4 as it is. Okay, and here it is, what is the integration of y square? Integration of y square is y cube divided by 3 over the limit what? 0 to 3. Over the limit 0 to 3. Now I should substitute upper limit minus of lower limit. So therefore 1 by 4 as it is, and here I will take this 1 by 3 outside. So here what you are getting y cube over the limit 0 to 3. Okay, now so required area is equal to 1 divided by 12. Now I should substitute upper limit. After that we have to substitute the lower limit. So what is the value of y? 3. So hence it is 3 cube minus of 0, because the lower limit is 0. So therefore required area is equal to 1 upon 12 into 3 cube. 3 cube means what? 3 cube means 27 minus of 0. So therefore 1 divided by 12 into 27 minus of 0 means 27 only. So therefore that is equal to 27 divided by 12, right? Or will cancel. So here it is 3 4s are 12 and 3 9s are 27. So therefore your answer is 9 by 4 square units. Okay, so therefore this gives the required area, that is 9 by 4. So here you should observe area of the region bounded by the curve x square equal to 4x, y axis with the line 0 to 3. So to solve such type of the problem, first you should see the given curve. So either it is a even power of x is there, or it is a even power of y is there, and you have to observe whether the area is lies on x axis or whether the area is lies on y axis, and with the line x equal to a or x equal to b or y equal to c and y is equal to d, depending on the area lies on x axis and y axis, you should apply the formula. Okay, so and this is the exercise problem. So here it is a exercise. So 8.1 is there. So this is the exercise 8.1 question number. So I think it is a and this is the question number 13. So in the exercise 8.1, this is the 13th question I have solved, and in the next class we will solve the exercise 8.1 from first question only, and we will continue in the next class. Thank you.